Good morning. This is a podcast about the Rutherford model of the atom from chapter 23 and how it actually relates a little bit to some of the specs for Orange County. And you may think, well, yeah, how does Orange County relate to an atom? Well, we're going to do that. We're going to make that relationship clear. First, let's talk about Rutherford's experiment. What he did was take a thin gold foil and fired alpha particles from a radioactive source at the gold foil. Now, they already knew that the alpha particle from this radioactive source had a charge equal to 2 protons, so plus 2e. Then they measured where those alpha particles ricocheted to. So they ricocheted off to all different kinds of angles, even backwards. So they knew that the alpha particle was interacting with something positive. When you get backwards scattering like that, or backwards ricochets, definitely you have got a positive object that you're interacting with. And that was different from what they thought about the atom at the time. They didn't know that there was such a thing as a positively charged part of it. They thought the whole thing was kind of like a little blob of green jello that was electrically charged positive, with little teeny electrons embedded in the jello. So anyways, they looked at all those ricochet angles, and then they analyzed the angles and figured out the speeds. Well, they knew the speeds of the alpha particle, so they figured out its kinetic energy and so forth. Then they worked out from that the electrical potential energy for whatever this charged object was that they were interacting with. And they were able to figure out, okay, it's got an upper limit on its size. In other words, we know it cannot be larger than this certain size. And so first of all, they knew actually it's very teeny, and the actual upper limit is that at most the nucleus, this positive thing that we're interacting with, is 1/100,000th of the size of the atom. So diameter for diameter, centimeter for centimeter, whatever the atom is, the nucleus is 1/100,000th of that size. Now, based on that experimental result, Rutherford thought, all right, well, I don't think we got a green jello atom. I think what we have is something more like the sun and planets. He thought, well, this little nucleus, it's pretty heavy and it's positive, and we think that the orbit of the electrons around the nucleus is a little bit like the orbit of, for instance, planets around the sun. Now, the planets orbiting the sun is accomplished by their gravitational interaction. Inside the atom, the electrons are bound in orbits around the nucleus by the electromagnetic interaction. But it's the same philosophy. You have bound orbits. Here's a famous sketch of that model. Little teeny bits of electrons orbiting around a little teeny nucleus in the middle. Now, in this sketch, the electrons in the nucleus, their sizes are not true to scale, and actually figuring out the true size scales for them is pretty difficult. But the basic concept here is, we think the electrons are orbiting. Now, since the time of Rutherford, we've refined our view. We still think of atoms as inhabiting orbits, but we don't really think of them in the same way that planets orbit the sun. And that's actually in chapter 24 when we tackle the de Broglie waves. Anyways, how does this all have to do with good old Orange County? We're trying to figure out atomic spectra. We have this Rutherford model that's refined. We think there's orbits and so forth, and we think that the atom is 100,000 times bigger than its little nucleus at the center. Well, the way that they're related to Orange County is basically through this little blurb on page 503, Are You on the Bus Yet? And they say, look, if you think of the nucleus as being the size of a basketball, how big would the actual atom be? So here we go. Let's set the proportion. Rutherford figured out the true ratio for nucleus to atom is 1 to 100,000. Now, if you say that the basketball is 1, how big is the atom going to be? Well, something that's equal to 100,000 basketballs. All right, well, it's nice. It's 100,000 basketballs lined up in a row. How big is the basketball? Well, diameter-wise, it's about 24 centimeters, or 0.24 meters. So as the textbook authors write in the blurb, 100,000 of those is going to be about 24,000 meters, or 24 kilometers. And 24 kilometers is 15 miles. And my wonderful students, that is halfway across Orange County. So what we're trying to look at here is, all right, if you say that the nucleus is about 1/100,000th of the size of an atom, that means that if the basketball were the nucleus, the atom itself would be halfway across Orange County. Now let's work on an example of that, and we'll get down to some brass tacks. Let's start at the Student Union at UCF main campus, and we'll just ask ourselves, all right, halfway across Orange County, all right, what's 24 kilometers away? What's 15 miles away from the Student Union, as a crow flies? Well, how about the airport, Orlando International? If you go as a crow flies and compute carefully, for instance, using Google Maps or something like that, you'll know that, for instance, from Subway in the Student Union to Starbucks in Terminal A, you're talking, that's fairly close to 24 kilometers. It's 21.554 kilometers, 13.383 miles. So yeah, when you're talking, all right, basketball is my nucleus, my atom is basically the distance from UCF out to the airport, maybe a little bit bigger than that. All right, so the upshot is that, as the textbook authors write on page 502, this means that atoms are almost entirely empty space. And that, my wonderful students, is an amazing thing to ponder.